In previous questions, we were given the product of some numbers which were raised to a certain power, such as it was 3 power x times 2 power x is equals to 10, for example. So when it was a multiplication, it was easier because we could simplify them and then apply log. But now it's an addition or subtraction of two exponential numbers and then it is equal to something. Now you cannot apply log directly. It becomes very difficult if you do so. So if we have any kind of such complex systems or a bit difficult systems, we use substitution to make them easier. So in this case, the question suggests to use the substitution of y equals to e power x. That means wherever you see e power x, you just put y in that equation and that will simplify it for you so that you find the value of y. But since our target is not finding the value of y, we need the value of x, so we will again back substitute y equals to e power x and find the value of x out of this. We are familiar with this type of simplifications and problems. We have done that in exercise 3.2 as well as in exercise 3.3. So let's see. We put e power x equals to y, and if e power x is equals to y, e power 2x is by default equal to y square. So it will become 2 times y squared minus 3 times y equal to 2. Now this is a simple quadratic equation and we can solve it in a variety of ways. We make a single equation on the left side. We have 2y squared minus 3 times y minus 2 equal to 0. We split the middle term, which is negative 3y, in negative 4y plus y. So taking the common factors out, we have y minus 2 times 2y plus 1 equal to 0. This leaves us with two roots, y equals to 2 or y equals to a negative half. We need to do back substitution because we are not interested in the value of y, we need the value of x. So we say y equals to e power x and the value of y is 2, so e power x is equals to 2. If that is the case, we take log on both sides. We remember that if we have base e, that means we need to apply natural log on both sides. So we apply natural log for e power x on the left equals to natural log of 2 on the right. Now log brings x down in the multiply, so we have x times log e equals to log 2. We know log e is equals to 1 because ln has the base e, and any number to the same base when taken log gives us 1. So ln e equals to 1. X times 1 will be x equal to ln 2. In some of the cases, if we leave our answer there, that's still acceptable, but if you use calculator and find the value of ln 2 and get 0.693, that's again better. Now we got one value for x. Since it's a quadratic equation, it has two values, or if it is e power 2x, it should get two values of x. So for the second value, we need the second part of the y that we got. We got y equals to a negative half. We put y equals to e power x, which is our back substitution, equal to negative half. As the same drill, we need to apply ln on both sides. So we apply ln e power x equals to ln a negative half. Now there is a problem. We cannot put a 0 in the log. We cannot put a negative number in the log. The domain of logarithmic functions is only non-negative numbers or positive numbers. Only positive numbers, not even non-negative numbers. So we reject this value of y. We just have x equals to 0.693. That's our answer. We move to second part of this question. It has e power x equals to 7 minus 12 times e power minus x. If I use e power x equal to y substitution, e power minus x becomes 1 upon y because e power minus x is equal to 1 upon e power x, which is 1 over y. So instead of e power x, I put y equals to 7 minus 12, and instead of e power minus x, we have 1 upon y, so that becomes 12 by y. Now in order to get rid of the y in denominator, we need to multiply y with all the parts on both sides. So we multiply y with this y, we multiply y with 7, we multiply y with negative 12 over 7. Now this y gets cancelled with this y, and we are left with minus 12 here. Minus 7 times y becomes 7y equals to y times y becomes y squared. Now the simplified form should be y squared minus 7y plus 12 equal to 0. I need to split the middle term. I find this very handy. If you want to go with the quadratic formula, you are allowed to go. So minus 7y is split into two parts, negative 3y and negative 4y. We take commons, we get y equals to 4 and y equals to 3. Now y was supposed to be e power x, so that means e power x is equals to 4 and e power x is equals to 3. We take ln on both sides, so that becomes x equals to ln 4 and x equals to ln 3. The value of ln 4 is 1.386 and the value of ln 3 is 1.098. We got both values for x, and that's the complete solution. We move to the C part. C part has e power 3x plus 2 times e power x equals to 3 times e power 2x. Now this has e power x, this has e power 2x, this has e power 3x. We have three different terms. If I put e power x equal to y, e power 2x will become y squared, e power 3x will become y cubed. Now I have y cubed plus 2 times y equals to 3 times y squared. We bring all the terms on the same side. We have y cubed minus 3 times y squared plus 2 times y equal to 0. Every term has y common in it. It has y, this one has y, this one also has y. So we take y out. We have y times y squared minus 3y plus 2 equal to 0. It's a product and that is equal to 0. It means either this y is equal to 0 or this bracket completely is equal to 0. So we set y equal to 0 or set y square minus 3y plus 2 equal to 0. If y is 0, that means e power x is equal to 0. In order to solve this, we take ln on both sides. So that gives me x times ln e equal to ln 0. We don't put 0 in log function, so we reject that case. But if y square minus 3y plus 2 is equal to 0, we proceed to split this negative 3y into two terms. We have negative 2y, negative y, the sum of them is negative 3y, the product is 2y squared. So we factorize it further and we are left with y minus 2 times y minus 1, and the product of which is equals to 0. That means y is equals to 2 or y is equals to 1. If y is equals to 2, we put e power x because we assumed or had taken the supposition that e power x is equals to y. So e power x is equals to 2. That means x ln e is equals to ln 2. ln e is 1, so x is equals to ln 2, which is equals to 0.693. Or if y is equals to 1, that means e power x is equals to 1. We take ln on both sides, so that becomes x ln e becomes ln 1. We know that the natural log of 1 will be equal to 0 because the log of any base, when you put 1 in the log of 1 to any base is equals to 0. So this becomes 0. From that part we get the value of x equal to 0. From here we get x is equals to 0.693. This part just does not make sense because it has got a 0 to be put in log. So we get only two valid values for x in this part. In question number 20, they are not providing us with a substitution. Rather, they are giving us the freedom to use any substitution that we think best fits our question. So the first part is 9 power x minus 4 equals to 3 power x plus 1. So if I simplify this, I have 9 power x minus 4 equals to 3 power x plus 1. 9 power x can be written as 3 power x whole power 2. Of course, minus 4 equals to 3 power x plus 1 can be split and written as 3 power x times 3. Now, if I have 3 power x in here and 3 power x on this side as well, it's good that I choose 3 power x and give it any different name or identity. So I choose 3 power x equals to y. So wherever there is 3 power x, I put y. So 3 power x whole square will become y square minus 4 equals to 3 times y. If I bring on it on the left side, I have y squared minus 3 times y minus 4 equal to 0. I split the middle term, I get two values for y, which is 4. So if I get y equals to 4, that means 3 power x equals to 4. I take log on both sides. I take log base 10 lg, because it's not e power x, it is 3 power x. It's any other base other than 3, other than e. So lg3 times x becomes equal to lg4. So x becomes lg4 divided by lg3. You can calculate it for yourselves. In the second part, we have y equals to -1. So if I put 3 power x equals to -1, I will have lg 3 power x equals to lg -1. We cannot give negative inputs to the log. It's like saying that I raise a positive number to any power. I can never have a negative answer for that. That makes no sense. Then the second part of the question is 2 e power x equals to 7 times the square root of e power x minus 3. So the smaller power term is e power x under square root. If I take that as y, the square of this will be equal to e power x equals to y square. So wherever I have e power x, I will put y square. Wherever I have square root of e power x, I will have put y there. Okay. So I will have 2y squared equals to 7y minus 3. I simplify it, I get two values for y. One is 3, the other is 3 by 2. So if y is equals to 3, that means the square root of e power x is equals to 3. That means e power x is equals to 3 square if I square on both sides. So that means e power x is equals to 9, or x ln e equals to ln 9. Ln e is 1, so x is equals to ln 9. If square root of e power x was equal to 3, I got the answer x is equals to 9. If I put square root of e power x equals to 3 by 2, I will get x is equals to ln 9 by 4. You can verify this for yourself.